we're going to talk about how to solve a quadratic equation using factoring. So in order to understand how to do that, we need to understand the zero product property, which just tells us that any number times 0 is 0, right? What would make this statement true? What times 16 would equal 0? The only possible number that could make that true is 0, right? It doesn't matter how many terms you're multiplying. In order for something you're multiplying to equal 0, at least one of those terms needs to equal 0. So that means we have different options. A could be equal to 0, that would be fine. Or B could be equal to 0. Or C could be equal to 0. Or D could be equal to 0. Under any of those 4 conditions, right? Or if we had 8 terms, we'd have 8 different possibilities. If we had 2 terms, we'd have 2 different possibilities. As long as one of those was equal to 0, this would satisfy the zero product property, and the product would be 0. Okay, how does that help us? So let's look at a couple of examples. So when we're solving using the zero product property, we're figuring out what value or values of x would make the equation true. Okay, letter A, x plus 3 times x plus 2. We have 2 different factors here, and in order for this to equal 0, either x plus 3 has to be equal to 0. Let's write that down. Either x plus 3 must equal 0, or x plus 2 must equal 0. We have 2 different options. So let's think about this. What would x have to be for x plus 3 to be 0? We can solve that. X would have to be negative 3 for that to be true. What would x have to be for x plus 2 to equal 0? We can solve that. X would have to equal negative 2. So in order for the entire expression of x plus 3 times x plus 2 to equal 0, that can only happen if x is equal to negative 3 or x is equal to negative 2. So we say that we have 2 possible solutions, because there are 2 x values that could make this equation equal 0. Okay, well, letter B, same thing. X could equal 0, or x plus 2 could equal 0. Well, we can solve this, so x could equal negative 2. Notice that x plus 0, that's already solved. You could pause and try the next 2 on your own. Again, we have 2 factors, so we know we'll have 2 solutions. If the factors were exactly the same, then we'd have 2 of the same solution. That's okay, we just call that a double root. So x could be a positive 7, or if I solve 2x plus 7, x could be a negative 7/2. That's okay, x could be a fraction or a decimal. Look at that, 2 solutions. Letter D, notice that that has 1, 2, 3 different factors. 1, 2, 3 x's. So we're actually going to have 3 solutions for this one. 5x could equal 0. Well, if we divide by 5, x would equal 0. There's one solution. If 4x minus 1 equals 0, we could add 1 to both sides. Well, then if 4x equals 1, we need to divide to isolate x, which means x could be 1/4, or 0.25. Last but not least, if x plus 52 equals 0, well, we could subtract 52. And hey, look at this, x equals negative 52. That's our zero product property. So it allows us to find the possibilities, right? So all of these different expressions had a couple different solutions, right? Different possible solutions that could make the equation equal 0. Now, how do we solve by factoring? It's a 2-step process, so those examples we just did, they were already factored. Sometimes the expression isn't factored. So what we need to do is make sure the quadratic equation is set equal to 0, right? Equal to 0. And then we can factor the quadratic, always look for a GCF first, and then we solve for x using that zero product property. So example number 2, solve by factoring. X squared plus 5x plus 6. Notice it's already equal to 0. Perfect. Well, I also noticed that there's no GCF. Okay, well then I'm just trying to factor x squared plus 5x equals 6. All right, so I want to figure out what could multiply to be 6 and add to be 5. Well, I could do 1 and 6 or 2 and 3. I'm thinking it's going to be positive, or I know it's going to be positive since both my signs are positive. Well, 1 and 6 would add to 7, 2 and 3 would add to 5. Hey, look at that. 2 and 3 must be my magic numbers. X plus 2 times x plus 3 equals 0. All right, so that was our step 2. We factored this. So now we go to step 3 and we solve. All right, here's our new step for today, solving. So we have this long equation, x plus 2 times x plus 3 equals 0. We're just going to split it up into two smaller equations. X plus 2 could equal 0, or x plus 3 could equal 0. We can easily solve these two linear equations. X could equal -2. There's one of our solutions that would make this work out. If we subtract 3, x could equal -3. Hey, there's the other solution that could make this work out. Now would be a good time to pause and try this next one. So example 3, solve by factoring. X squared plus 7x equals 0. Okay, well, it's equal to 0, right? So we can just get started. This one is going to have a GCF, right? Notice that I don't have a C value. My C value is 0 for this one. So my GCF is x. Well, if I factor that out, I have x times x plus 7. Notice that x plus 7, hey, that is linear. So I'm actually done factoring this. I've got my two factors. X could equal 0, or x plus 7 could equal 0. Well, x equals 0, that's already a solution. X plus 7, we could subtract 7 to both sides, and there is our second solution. X equals -7. Let's do one more example here. Solve by factoring. X squared plus 7x equals 8. This is equal to 8. We keep saying it needs to be equal to 0. So we actually have to do something here to fix this. I'm going to subtract 8 from both sides. How does that help me? That takes my equation and turns it into x squared plus 7x minus 8 equals 0, right? 8 minus 8 is 0. And basically, I just moved my 8 to the other side. And remember, because of our inverse operations, if you move something to the other side when you're adding and subtracting, that sign changes. Okay, well now I can factor this. Hey, look, it's equal to 0. So looking at it, there's no GCF, but I always have to check just in case. So that just means I can figure out my magic numbers. Well, it's going to multiply to be -8 and add to be a +7. Let's see, 1 and 8, 2 and 4 are my possibilities. And I see that this is a -8. So the only way to multiply to be a negative is if I've got a positive and a negative here. Okay, well, I don't think 2 and 4 are going to be able to give me 7, so I'm thinking about -1 and +8, or +1 and -8. Well, that's the difference between a +7 or a -7, so -1 and +8 must be my magic numbers. Okay, I factored it, but remember, what we're really trying to do is solve for x. So my last step is to take both of these and set them equal to 0. Because now I can solve for x. X could be -8, or x could be +1. All right, so that's how you